Okay, so what I want to talk about today is something that definitely was the main focus of your last year. And that is, oops, that's what I always do. And remember, if I write it on the screen, you write it in your notes. They've done study after study of memory. And every study says you remember your material better if you write it down. And typing even, you don't remember it as well when you type it. If you write it by hand, it's going to help you remember and learn a topic better. So I do want you, even if you're just copying what I've got, I want you to follow along and add these to your own personal notes. And like I said last week, you guys are old enough, I'm not doing a note check for you, but I do expect that you're going to have your own organizational system, and you're going to stick to it. Alright, so last year, no matter which math class you took, you should have gone over some things that are characteristics, and I want to focus on especially of graphs right now. With the graphs, can you name for me what are some important characteristics that we looked for as we studied graphs in your previous classes?
The shape.
The shape was a huge one. I want to make a list of everything we can come up with.
I think it was the asymptote.
Does it have any asymptotes? That's huge. That's going to definitely play in part this year. Does it have an asymptote? And if it does, where? And by the way, when we talk about asymptotes, what three, I know we usually only study two, but there actually are three. What three types of asymptotes are we going to come across? All right, Aurora's modeling for us. And when we talk asymptotes, we're going to talk about the verticals, the one we spent the most time with. We may have touched on the horizontal. And you also, the one that is usually the last one you touch on is called the slant. Now technically you could actually, there are more asymptotes than that, but you will not need to worry about any more asymptotes than that. So vertical, of course, is when we've got something like this. Horizontal is when we have something like this. And slant, by definition, is something like this. So we can see our functions themselves might do something like this. Or like this. Or like this. Now, in my class, I know we didn't do slant, and I don't remember if we did horizontal. I kind of don't think we spent much time on horizontal. I think we just only talked about it with your basic rational functions, if you had me for math last year. And as you write things down, be thinking, what other characteristics did we talk about in all of the math you have ever done up till now?
I mean, it's pretty simple, but the x and y intercepts.
No, it's simple, but that's huge. X and y intercepts, because those give us valuable pieces of information. Typically, your y-intercept, just to add some notes here, that's your starting value. We can manipulate the math so it's not actually the starting value, but in almost everything we do, we try to make it the starting value to make it easier for ourselves. And then the x-intercepts are what we call, I like to call them zeros. There are different names for them, but usually it's a significant point. It could be like if you're talking money, it's a break-even point. If you're talking dimensions, it's going to be your boundary points. Somehow, it provides boundaries. And if you were in my class, I know that these characteristics, we had, I think, 10 or 12 that we went through, and it was in the very, very first lesson of the year, and then we kept bringing that list back all year long. If you had Lutz or Strong, I don't know where in the book you covered this, but pre-calculus is all about the function, so there's no way you wouldn't have.
Domain and range.
Oh my goodness, that one, that's the first one that's on my list, because that is such a huge topic. Domain and range. And just to get it, to say it once, domain goes with what? Show me with your arms. I have to go way up here because my camera's way up here. Domain is the possible x's. Range is the possible y's. And I love looking, I said this last week, love looking for dumb tricks that help me remember what goes with what. Alphabetically, D comes before R, and X comes before Y. So the first thing in the alphabet with the first thing in the alphabet, second thing in the alphabet with the second thing in the alphabet. I know I always had trouble remembering which one went with which until I used that trick. It's not the only trick you can find, but it is a helpful one. And ultimately, too, let's do... I feel limited on my colors a little bit. What this is asking for is where to find the graph. And let me tell you, you kids are spoiled. Eventually you'll have things that you can say to the next generation that they're spoiled on too. But here's the issue. I'm going to type a function in on the screen that you can't see and move it over to your other screen. Can't tell you in my career how many times I've dealt with this. Okay, I'm going to cover up what's on your screen for a second. I'll take it away in a moment. But I cannot tell you, at the start of my career and when I was a student, everything was on a TI calculator. There was no Desmos. And what happened is a student would type in a function, and every stinking time this would happen, because we'd have the same calculators from class to class, and they would pull up their graph and they would just see nothingness. And they go, Miss Whitbeck, my calculator's broken. It doesn't show up. I know what x squared looks like. It should show up. And I would explain to them every single time that the window was set to whatever the last person's function was. It automatically, they had used the domain and range to find their own window. And window just means, like here on the x's, I'm going from, looks like 14 to 34 on the x, and from 6 to 24 on the y. That's the window. And they had needed that window for their function, but then they had deleted their function. The calculator would default to that window. And when you put in a new function, it just goes to where it was last. Now you guys are spoiled because you have Desmos, and Desmos, no matter how you graph it, it'll immediately pop up with a domain and range that might not be the one you want, but it still shows you where the graph is. It's a much better starting point. So, and I'm going to use Desmos like crazy in this class because it does help. Now, we can't use Desmos on the AP test. I will bring that up. You do need to have a calculator and or know how to use a TI, preferably calculator. You can, by the way, while we're on the topic, you can get Casio, you can get HP. Casios are much, much, much cheaper, but they're also what you pay for in cheapness, you deal with frustration because they set it up in ways that don't make sense. And HPs are both expensive and don't make sense. So it's not a great option there in either place. But your TI calculators are pretty straightforward on how to use them. By now, I would hope you'd all have calculators. End of the year, I know, but I'll go ahead and say you can check them out from me. But I've got TI Inspires, and those ones do have a little bit of learning curve, at least for people like me who learned on 83s and 84s. But for the AP test, you will need a calculator. Okay. Back to this. We have 4, and I know that there are many, many more. But I want to hear from you. What other values can you think of? What other characteristics do we have in graphs that help us describe graphs to make them unique?
Wasn't one of them like the point of symmetry?
Does it have any symmetry? That's a good one. And that right there in my class, I know we didn't talk about this, but in pre-calc, did you talk about even functions and odd functions? That came up? Okay. So if you had me for class, don't worry, we'll catch you back up. But we are going to talk about even functions, odd functions, and neither. They don't have to be even or odd. But even and odd functions are just going to be a way to say in different words if it has symmetry. In your Barron's book, if you start flipping through it, you will find places where in the explanation it will say this is true because this is an even function. And so I do want you to understand what that means, but it's just a reference to its symmetry.